Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform. So basically guys, this is our GATE 2021 exam syllabus. This chemistry syllabus is compulsory for all Excel candidates. In the previous lectures, we have completed section 1 named atomic structure and periodicity. And now in this particular section, we are going to study about structure and bonding. Syllabus that we have covered till now is these topics. This is your section 1 topics, and in particular section 2 we have covered covalent bond in the previous lecture. And in this particular lecture, we are going to talk about next strongest bond, ionic bond. The chemical bond formed between two or more atoms as a result of complete transfer of one or more electron from one atom to another is called ionic bond. So basically, as you know, in the previous bond, in the covalent bond, there was a sharing of electrons between two atoms. While in case of ionic bond, there is a complete transfer of one or more electron from one atom to the another. And when this complete transfer of electron takes place between two atoms or more than two atoms, the formation of ionic bond takes place. When an atom loses an electron, it gains a positive sign. It becomes a positive ion, and these positive ions came under the group number first A to third A. And also when an atom gains electron, it gets the negative ion, or it becomes negative ion, and this came under the group 5th A to 7th A. This ionic bond is always formed between two ions. As you know, positive ion and negative ion exist in nature, cation and anion. So basically, electrostatic force of attraction between cation and anion is called ionic bond or electrovalent bond. This ionic bond is also known as electrovalent bond. If you want to see the nature of ionic bond, if you want to know the strength of ionic bond, you should know about the electronegativity difference of these particular two atoms, which makes a particular molecule. Next, we have the conditions for forming ionic bond. What are the conditions when the ionic bond will form? So basically, there are three major factors on which the formation of ionic bond depends. Number one factor is ionization energy. As you know, in the previous lecture, we have learned about the ionization energy, that is, amount of energy required to remove an electron from the outermost orbit. The energy which is required to remove an electron from the outermost orbit of a particular atom is called as ionization energy. And when you remove an electron, your atom will gain a positive sign, or it becomes a positive ion, that is known as cation. As the ionization energy decreases, there is the greatest tendency to form the cation. This is very important. As the ionization energy decreases, there is the greatest tendency to form cation, as you can see in this particular example. Next, we have another important factor, that is electron affinity. As you know, electron affinity is the energy that is released when an electron is added to a particular atom. And when an electron is added, when an atom gains an electron, it becomes negative sign, or it becomes negative ion, that is known as anion. As you have seen here, if the atom gains electron, it becomes negative, that's why it is known as anion. And when an atom loses electron, gives electron to another atom, it becomes positive sign or becomes cation. As the electron affinity increases, there is the greatest tendency to form an anion, as you can see in this particular halogen ions order. Next factor is lattice energy. This is very important factor because this lattice energy will tell you the order of ionic compounds, order of the stability of ionic compounds. So you have to learn this point, you have to mark this point, this lattice energy. This is very important point. I have marked it. Amount of energy released when a 1 mole of crystal lattice is formed is known as your lattice energy. As the lattice energy increases, there will be the greatest tendency to be the stable ionic compound. Next, overall lowering of energy. You know it very well. For the formation of stable molecule, the energy should be minimum. So, always the atoms combine to form a molecule to decrease their energy to gain the maximum stability. So energy must be released during the bond formation to lower their energy. These energy changes are involved in the following two steps. When an atom A is given ionization energy, means an electron is being removed from atom A, it becomes a positive ion or electron, and B atom, when B atom has been given an electron, it becomes negative ion or anion, and the electron affinity is used. Next is the physical properties of ionic compound. There are various physical properties of ionic compounds which we are going to study. Number one is physical state. Ionic compounds are the hard, crystalline and brittle due to the strong electrostatic force of attraction. As you know, ionic compounds came under the category of strong bonds, which we have learned in the previous lecture. Strong bonds has the energy of 200 kilojoule per mole. Next property is isomorphism. Two compounds or two atoms, two molecules are said to be isomorphs of each other when they have the similar or same formula while they have the different structure. Or two compounds are said to be isomorphous if they have the similar number of electron. Next property is boiling and melting point. These ionic compounds has high BP and MP due to the strong electrostatic force of attraction. Number fourth point is conductivity. Conductivity of ionic compounds totally depends on the ionic mobility. Ionic mobility means the free ions present in their particular solution. As you know, the conductance of electricity can happen only in the presence of free H plus ions or OH minus ions. Next point is solubility. These ionic compounds are highly soluble in water, which means they are soluble in polar solvent. Polar solvent means the solvents which have H plus or OH minus ion concentration. This solubility depends on the two major factor. Number one is lattice energy and number two is hydration energy. Solubility is inversely proportional to lattice energy while solubility is directly proportional to hydration energy. Next we have the most important cycle of this particular important lecture, that is Born-Haber cycle. This cycle is very important as for the GATE exam, as for all the competitive exam, because a number of times these questions have been asked in various competitive exam from this topic. So basically Born-Haber cycle applies only to fully ionic solids such as certain alkyl halides. So basically Born-Haber cycle is being designed for the certain alkyl halides. Most compound includes covalent and ionic contribution to chemical bonding and to the lattice energy, which is represented by an extended Born-Haber thermodynamic cycle. This cycle, which you can see on this screen is represented is known as Born-Haber thermodynamic cycle. Thermodynamic cycle because this cycle involves a number of energies. The extended Born-Haber cycle can be used to estimate the polarity and the atomic charges of the polar compound. So let's get started this Born-Haber cycle. So as you know, this Born-Haber cycle is applied for certain alkyl halides. As you can see, the halides, the atoms, the metals which has been used in this particular example is sodium, half mole of chlorine, and this delta HF represents the formation of energy. This delta H is known as your energy and F is your formation. When this sodium reacts with chlorine, half mole of chlorine, this forms a solid NaCl. But this step do not take place directly. For the formation of NaCl, for the formation of 1 mole of NaCl, you required some intermediate step. Some intermediate steps happens between the formation of NaCl. Let's see the intermediate steps. First of all, this sodium solid is being converted into sodium gas. When an element changes its state from solid to gas, sublimation energy is required. When this sodium gas is changing into its consecutive ion, sodium plus ion, that is known as ionization energy. Because as you know, ionization energy is required to convert an atom into its consecutive ion. Next, when you convert half mole of chlorine gas into chlorine gaseous atom, you required bond dissociation energy to dissociate the moles of this chlorine atom. And this half of bond dissociation energy will convert this half mole of chlorine into chlorine gas. And when you change this chlorine gas into its consecutive chloride ion, you required electron affinity. And this electron affinity will change this chloride gas into chlorine ion. Now you have sodium ion, sodium positive ion, and chlorine minus ion, negative anion. When this reaction takes place, when the bond between sodium and chlorine takes place, you required an energy that is known as lattice energy for the formation of 1 mole of crystalline structure. And this crystalline structure will become NaCl. So basically, as you can see, as you have seen, a number of energies are required for the formation of ionic bond. These ionic energies, these bonds between two atoms, between two ions, give the formation of NaCl. So basically, delta H formation, delta formation of energy requires 5 type of energy: sublimation energy, ionization energy, bond dissociation energy, divided by 2 means half of bond dissociation energy, electron affinity, and lattice energy. For the formation of any crystalline structure, these 2 energies, electron affinity and lattice energy, are in exothermic condition, while rest of the first 3 energies are in endothermic condition. Endothermic condition means when the energy is being absorbed, and exothermic reaction means when the heat is being released, or endothermic means when the heat is being absorbed. Next, we have the application of BHC or Born-Haber cycle. This is the very important application of Born-Haber cycle because it gives the sublimation energy of metals and ionization enthalpy of metals, that the metal has low sublimation and ionization energy, while non-metals has low bond dissociation energy and high electron affinity, and also about the high lattice energy of non-metals. This is the application of Born-Haber cycle, which you have to remember. Next, this slide is also very important because this gives you the most important orders of electron affinity, bond dissociation energy and ionic bond formation tendency of halogen group. So basically you have to learn this order because a number of times questions have been asked in various competitive exams from this particular slide. I have designed this. You have to learn it. You have to write this order in a particular notebook and you have to learn them. Now we have the lattice energy. So lattice energy, you know what is lattice energy? The amount of energy required to convert a 1 mole to form a 1 mole of crystalline structure from its consecutive ions. So basically lattice energy is directly proportional to charge upon size. As you increases the charge, lattice energy will increases. As you increases the size, lattice energy will decreases. If lattice energy increases, attraction between cation and anion will increases. Means the strength of cation and anion will increases. That's why the stability of ionic compound will increases. This is the most important point that says if lattice energy increases, stability of ionic compounds increases. If some question asked you about the order of ionic compounds, simply you have to see the order of lattice energy. And order of lattice energy depends on this particular point. Lattice energy is directly proportional to charge upon size. So as you can see in this particular point number 3, stability of ionic compound is directly proportional to lattice energy, or you can say stability of ionic compounds is directly proportional to charge or size. Next we have the factors affecting solubility. If lattice energy increases, ionic bond strength will increases and ionization decreases and solubility decreases. If hydration energy increases, solubility increases, and hydration energy also depends upon charge upon size ratio. Now this is an example to find out the order of lattice energy. So let's see this example. Let's understand the concept of lattice energy. You have given an order NaCl, MgO, ALN and TiC. You have to tell the order of lattice energy in this particular series. As you can see, when you move from NaCl to TiC, the charge is being increased. That's why if charge is increasing, the lattice energy will also increase. Next order is for NaF, NaCl, NaBr and NaI. This particular order comes under the group 17. That is your halogen group. When you move from top to bottom in particular group, the size of anion will increases. If the size of anion will increase, the lattice energy will decrease. Now there is an exception of this lattice energy order which you have to learn, and the exception is for the second group elements, that is the carbonates and sulfates of second group element BeCO3, MgCO3, CaCO3, SrCO3, BaCO3, and for the same for sulfate group. So now as you can see, from BeCO3 to BaCO3 along the group, lattice energy is being increased. But as you have seen, along the group, if size increases, lattice energy should decreases. But it is increasing in both the cases, carbonate and sulfate. This lattice energy is being increasing due to the specific crystalline structure. You have to learn these orders, these two orders, because this is the exception of the order of lattice energy. So here I would suggest please learn this order accordingly. I have highlighted this order. You have to learn this, and the reason is due to specific crystalline structure. Okay, so next is found out the order of lattice energy of the following. This is the most important question. If you have understand the concept of lattice energy, you will easily solve this question. Here I would suggest please pause your video and solve it quickly by yourself. Okay guys, let's see the solution for the following question. Okay, number 1 is your for Na2O, MgO, Al2O3. When you move along the period, you will see the charge is being increasing. So if charge is increasing, the lattice energy should increases, and the order comes out to be this. For second, LiCl, NaCl, KCl, RbCl and CsCl, as the size of cation increases along the group, you will see the lattice energy will decreases because lattice energy is inversely proportional to the size. I hope now you all are cleared about this ionic bond, about the lattice energy, and you will solve all the questions accordingly. Now, in case if you are new here on this channel, on our YouTube channel Gurmantra Shiksha Ka Granth, please do like, share and subscribe. You can also join our Telegram channel for more new updates regarding to your exam. You can also get free PDF and notes over this channel. For further queries, you can mail us on tanejanehaofficial@gmail.com, or you can contact us on this given number. Thank you very much guys. I hope